The last topic from our CONM syllabus is your Romberg method, which falls under differential numerical differentiation and integration. So it falls under the integration part of the module. So what happens is that in Romberg method, you have to develop a table. Now the table depends upon what value of age you are selecting. Depending upon your age, how many times you divide this age, based on that this formula is derived. So let's assume that I am dividing my age up to 8 terms. So first I of age, then I of age by 2. I will explain to you what is I, and we will have a better picture when you see a numerical. So we will discuss that. Then you divide age by 4, then you divide age by 8. So you are repeatedly dividing. So first was age, then you divided age by 2, then you divided this age by 2 with again 2, so it is age by 2 divided by 2, so basically it's age by 4. Then you divided age by 4 by 2 again, age by 4 by 2 again, so it's basically age by 8, age by 8. So in this way you have kept on dividing it. So once you know this, from the first two you are calculating this I age comma age by 2, so age by 2. From these two you are calculating I age by 2 and age by 4. Then from these two you are getting I age by 4 and age by 5. Then from these two you are calculating I age. See, from these two what are the common things? So age is there, so age is there. Age by 2 common to both of them, so age by 2 is just taken 1, age by 4, so age by 4. Similarly, from these two, age by 2 is there, so age by 2 is there. Age by 4 is common, so age by 4 is common, so age by 8 is there, age by 8 is there. Again, from these two, you are taking age by 2, age by 2 is common, so age by 2 is there. Age by 4 is common, so age by 4 is there, age by 8 is there, age by 8 is there. So this is your final answer. This is basically your final answer. So what are these I of age? These are I of age. What are these I of age? These are basically from the trapezoidal rule. You have already seen. You can go through the module and the video. We have discussed the trapezoidal rule. In the trapezoidal rule, using these are basically this I of age, this I of age 2, I of age by 4, I of age 8. These are derived from trapezoidal rules. So these are from trapezoidal rules. So let's see the numerical and how to solve it. Suppose you are asked to find out the integration of this function, which is 1 by x 1 plus x from the range 0 and 1. So first what you do is that you will be using trapezoidal rule and calculating your age. So let me take age to be 0.5. If my age is 0.5, then I can reach my final destination, which is 1, from 0 to 1 in 2 steps. So x naught, so I know, just put, if it is x naught, just put x naught over here, 0 over here, so 1 by 1 plus 0, because what is your function? Your function is your 1 by 1 plus x, so your function is 1 by 1 plus x. If x is 0, then what is f of x? F of x is your 1. So if x naught is 0, then y naught is 1. Similarly, if x1 is 0.5, then just put 0.5 in place of x, you can calculate your y1. Then in order to calculate your x2, just add 0.5 with x1 and you can calculate your x2. Put this x2 in this function and you can calculate your y2. So you have your x1, y1, x2, y2 and x0, y0. So you can then put them on the trapezoidal formula and calculate your for this function. So for whom you have calculated this, for h is equals to 0.5 you have calculated this. So your I of h is this value. Now you have to divide again your h by 2. So what was my age? Age was 0.5, so I have divided 0.5 with 2. Now it is 0.25. Since it is 0.25, how many steps do I need to calculate in order to reach from 0 to 1? There are 4 steps now. 1, 2, 3, 4. So for each x, just put this x value on your equation and calculate your y. So for x2 you have y2, for x3 you have y3, for x4 you have y4. Once you have these values, put them in the trapezoidal formula and calculate your I age by 2. Similarly, do it for I age by 3, I age by 4 and I age by 5. So you can calculate your I age by 2, I age by 4, I age by 2, I age by 4. Now in this numerical I have calculated only up to I h by 4. Now since I have calculated only I h by 4, so you see from this formula, I have calculated only I h by 2, I h by 2 and I h by 4. Since I have calculated them, so from these two I can find this and I can find this. From these two I can find this, and this will be my final answer because there is nothing else. This is what we have done over here. Now if in this numerical I would have calculated after I h by 4, I would have calculated I h by 8 also. In that case I would have used the last term also over here, and then I would have calculated this up to this point. But since I have not done that and I have only calculated up to I h by 4, so I am going to calculate this term and this term. So you see it's over there. I h by 4 h by 2. Now this is the Romberg's formula. So I h comma h by 2, this is the Romberg's formula. 4 of I h by 2. See, the pattern remains the same only. As you can see over here, it's 1/3. 1/3 is common for all of them. 1/3 is common for all of them. 4 is common for all of them. And then between this I, what will be the value? That depends upon what is present over here. So h by 2, it's h, so it's h. Similarly, since h by 2 is over here, as h was over here, h was over here. Since h by 2 is over here, so h by 2 is over here, h is over here, h is over here. So just go through this formula, you will see there is a pattern. And as I have shown to you, you will be calculating this, and this will be a final answer. So as you can see, this, and this is your final answer. So this is your Romberg method. Do it yourself and you will be able to understand it. So with this we have completed our entire CONM syllabus. Thank you.